Stage is all yours.
Thank you. So welcome everybody to our journey with PrivateAI, where we dream of solving the impossible using the technologies that were previously unavailable. So we started our journey actually not with AI, but rather with longevity, also known as life extension technologies, about 4 years ago. And the goal was simple, is to discover and make a bet in the form of investments in the most promising technologies, solutions, and research that could increase human lifespan or health span. And this was our dream, the dream of living longer, living healthier, and who knows, maybe living forever. As we started progressing in our journey, though, what we came to understand is through repetitive experiments and projects that we worked on with scientists and researchers, is that an endeavor as complex as longevity requires up-to-date research, data, and knowledge form in so many scientific fields that it opens up a lot of issues about the data governance, data management. Scientists and researchers, for instance, they're not willing to share their data. They may be reluctant about providing it to other parties because they're afraid of the data possibly getting stolen, copied, or absorbed into neural networks without them being compensated for it. And you have the basic issues that data creators have about sensitivity of their data. They form diverse sources of data, which makes it difficult to piece all of these things together. The effort to produce this data is not necessarily compensated. And then finally, there's a huge fragmentation amongst the data silos. Therefore, data creators' problems needed to be addressed first. And we realized that actually these problems were not only endemic for the longevity space, but for other areas of science as well. So we focused on generalizing this problem to scientific research in general, and we started our journey on building the platform. So the stage one was actually to build a domain-agnostic data governance platform that would have stuff like peer-to-peer data sharing, proving data availability, doing IP-backed NFTs and DAOs, basically using Web3 constructs mixed with intellectual property to help people monetize them and share them. They also offered binary privacy, meaning that you could either open it up entirely or make it fully public on the blockchain, or you keep it private. There was no in-between. And then finally, it was focused a lot on showcasing and analytics. So we ran a few such experiments through scientific networks at various clusters, such as Ivy League universities in the US, Harvard, as well as MIT, as well as Oxford and ETH Zurich. And we also started discovering some commonalities that in the complex fields of innovation, such as longevity, for instance, even having access to the knowledge that was built, no human brain power, no matter how brilliant and experienced, would be able to spot all the potential patterns and relationships between this knowledge. So as a result, we realized that we needed to combine multiple niches together, including such stuff as stem cells research, bioinformatics, genome sequencing, personalized medicine, and so on and so forth. So each of these is a huge niche of its own. So we needed kind of a superhuman intelligence to give us solutions to the challenges we were attempting to solve. And that's where we started going towards stage two of our development, creating what we call an AI native distributed platform. You have a super high level overview here. Importantly, in this platform, the key values of version 1 have been preserved and expanded on. So the key values are sovereign data ownership, monetization of data, as well as sharing incentives for scientists and researchers. A lot of them, they work on the notion that science itself needs advancement and that sharing it is important. However, in many cases, they don't have any financial motivation to further propagate their research. So basically, we started collaborating with different stakeholders who could also provide their data to companies that are looking for high-quality data for AI purposes. So the main change we implemented is that the processes we built in were native to AI platform and not just sharing data in a data governance platform. So the platform we built was focused on creating domain-specific large language models using data and IP from proprietary studies. And the platform provides valuable insights for researchers from various disciplines. And we ensure the data privacy and security using technologies such as fully homomorphic encryption, allowing the models to learn without revealing the underlying information. So we believe this is one of the important aspects of the AI industry in general. You need to be able to learn from the data, even if it's not visible itself. Right now, pretty much all of the large companies, they just scrape a lot of data. They just use any sources they can get their hands on, and data owners very often are not compensated. So around the time when our alpha version of our platform was tested, a little startup called OpenAI released their ChatGPT for the public use. The irony is, though, despite having the name of OpenAI, the highly opaque data collecting methods and the number of stakeholders from the obscure scientists, authors, and different parties claiming that their data was not properly used or they were not compensated, makes it a bit ironic that the name is OpenAI because it's anything but open. So we decided that we need to make a counterbalance to it in order to enable it to run in a decentralized and peer-to-peer efforts, as well as to give data owners and producers an alternative to OpenAI, to give them their very own private AI. So why knowledge graphs specifically? So let me first define what knowledge graphs are for those who are less knowledgeable about this. So knowledge graph is basically, it's a unit that captures relationships between different concepts in a structured way. So it improves the logical reasoning and capacity of AI models. It also helps detecting various hidden links between different subjects and different predicting outcomes. So through the platform, we enable visual representation of complex kinds of data, and we enable researchers to explore and uncover relationships within. They facilitate the discovery of connections between different concepts within a specific topic. So you can see different examples of how scientific papers, once uploaded to the platform, you build out a mapping of different pieces of knowledge. You have the number of nodes and number of edges, which basically indicates how many different concepts are present in a particular research paper. You also have a built-in AI assistant that helps you actually get the useful information out of these documents, importantly preserving the original document itself. So if you choose not to share your actual IP, your actual data, you can keep it private whilst simply sharing the findings and different relationships between the different materials to your users. So they can interact, asking some specific questions, but they will never get the original data, which makes it useful, at the same time enabling it to keep protected. This is another example of data core structure of some other paperwork, where there are two specific topics identified in the knowledge graphs. And importantly, knowledge graphs are also the building blocks for open source conversational AI. So right now, conversational AI cannot analyze heterogeneous medical data, for instance, due to terminology differences. So patients are often frustrated when advanced prompt engineering is required to obtain recommendations or deeper insights from LLMs. So typically, if you go and ask for any sort of medical-related questions to any GenAI solutions, they give you a very average advice that you could find on Yahoo Answers or Quora or some forums, which is not great. Knowledge graphs, as a unit of machine learning, radically improves the reasoning, the logical reasoning capacity of AI models, and it also enables them to see the context of the discussion. So therefore, it actually gives a more human-like critical thinking abilities and context awareness. So from that perspective, the recommendations and insights that the platform can give is significantly more detailed, personalized, and advanced. And you, as the owner of the data, you can actually also choose to just publish the data on the open source, so open it up entirely, and you can start generating income in the form of cryptocurrencies by having your data available, by letting others use it. Importantly, the more often your data is used by different companies training their own LLMs or their data analytics companies, the more money you make. So it's basically a royalty-based system that blockchain and Web3 solutions are very practical for. So why generally is there a good interconnectivity between Web3 and knowledge graphs? So for AI to develop reasoning skills, its governing ontology must support learning. And if the algorithm is based on an insufficient amount of data, it will produce inaccurate and low-quality outputs. So to deliver fast and unbiased advice, retrieval-augmented generation should tune in to self-updating dynamic knowledge graphs. Most of the industrial knowledge graphs today are non-dynamic. They updated are on average twice a year. So imagine how outdated most of that information is. Therefore, our approach is to maintain continuous state-of-the-graph approach where there is a human element introduced into the loop where people are providing up-to-date scientific-backed information and they earn money by providing this data. In result, we actually have a knowledge graph that's dynamic, constantly growing, and is updated regularly by the scientific community. And incentivized by these token-based revenues, then the in-house council members, they can perform stamped links and adding different elements to the platform. So you have the crowdsourcing element, and you have also a broadcast from open source, publicly available sources such as arXiv, bioRxiv, and PubMed. So generally, as I said, we are focused in particular on the longevity space. So the applications for that include stuff such as accelerated drug discovery, where you develop different drug components and understanding of disease mechanisms, and having a knowledge graph mapping all these different processes is hugely useful. That makes stuff like personalized medicine possible, where you can actually give personalized opinions to people depending on their context and decode more complex data, including stuff such as genetic data that could make a breakthrough in the gene therapy, genetic order mismatch, or some other genetic problems. Finally, this can also be used for solving some rare diseases and analyzing aging processes generally by combining data sets from diverse segments of biology, chemistry, medicine, in particular clinical studies, and find some patterns between lifestyle choices, genetics, and epigenetics to find some breakthrough longevity research solutions. So the team behind it are all unicorn builders. Between the 6 most senior people on the team, we have each either co-founded or led at a C-level a crypto unicorn with multi-billion-dollar market caps. And we all are united by this idea of using the combination of Web3 and AI to make some breakthrough life extension discoveries. It's a bit of a religious mission for us as well, because we were just also motivated by possibly finding some solutions to live longer, or at least live healthier longer. And we have also, to expand our dream and to bring other dreamers on board, we've opened up what we call a hyper accelerator for DeSci and AI startups. DeSci is a decentralized science. It's basically a Web3 approach to solving inefficiencies of the scientific community and to bring in stuff such as crowdfunding, crowdsourcing, and open source collaboration to the scientific communities. So we are focused on helping science-heavy AI projects that could benefit from distributed infrastructure as well as knowledge monetization. We only look at those business models that are future-proof in the AI era, that are defensible against the giants such as OpenAI, such as other competitors, Google, and so forth. And in particular, there is the spirit of decentralization, sovereign data ownership, and censorship resistance, so that we could have a decentralized answer to the global giants. And finally, we have first such projects already being announced today. Actually, it's the first time we're announcing it. It's called Gin Tonic, and it's a global marketplace for sourcing distributed compute. I think half of the presentations today, they focused on how little GPU compute power there is available, how many problems there are with sourcing it, and that there is a lot of hardware lying around unused that could be used for solving AI-related challenges. So the first project of our ecosystem is going to focus on that particular challenge of repurposing and reusing hardware and GPUs to solve AI-related tasks. And people can mine coins in return. They'll get rewards. It's called gin. So we say, use your GPU to distill some gin. Generally speaking, this project will serve as the backend, as the compute layer for our platform. So yeah, it's not possible to reach the stars and live forever yet. And we are working on that, and we invite us to join us. We're hiring, we're looking for more partners, and we have a booth right here at Super AI. Thank you.